Things are moving so fast in software development these days, it's almost hard to keep up, I mean, it feels like just yesterday we were all excited about autocomplete, and now suddenly we're talking about AI that can write entire applications. It's like the whole foundation is shifting under our feet.
I agree. It really does feel like a major transformation is underway. And the thing is, these advancements in AI, they're not just theoretical anymore. They're actually starting to fundamentally change how we approach building software in a really practical sense.
Yeah, for sure. And that's exactly what we're diving into today in this deep dive. We've been digging into some really interesting research and expert analysis about this whole evolution, how traditional coding, the way we've always done things, is starting to give way to these new AI-powered methods. Specifically, we're going to be looking at this idea of vibe coding, which has been getting a lot of buzz lately, and then even further down the line, this concept of fully agentic coding, which sounds pretty futuristic, to be honest.
Yeah, fully agentic coding, that definitely sounds like something out of a sci-fi movie, doesn't it? But the reality is we're actually starting to see the building blocks of that kind of future emerging right now. And we've got a really interesting collection of articles and analyses that we're going to be drawing on today to kind of map out this whole transition and hopefully demystify some of these concepts along the way.
Right. So our goal today is to really break it down for you. What do these terms actually mean? What's happening in the industry right now? And where might things be headed in the future? We want to cut through all the hype and give you a clear, concise understanding of this whole rapidly changing landscape and really get to the core of what the potential future implications might be. So to kick things off, let's start with this idea of vibe coding. I mean, it's a pretty catchy term, but what does it actually mean in practical terms? What's actually going on there?
So at its core, vibe coding is this new way of programming that really heavily relies on AI. And the key difference, the thing that sets it apart from traditional coding, is how developers are actually interacting with the system. So instead of, sitting there writing code line by line, what they're doing is using natural language prompts. Essentially, they're talking to the AI, if you will, and these large language models, these AI systems, are actually generating the code based on those instructions.
So it's like instead of writing out the specific commands, you're describing what you want the code to do in plain English, and the AI is figuring out how to actually make that happen.
Exactly. And it really does feel a lot more intuitive, a lot more conversational, almost like you're having a back and forth with the AI rather than just giving it a rigid set of instructions.
Vibe coding. It's a very kind of evocative term, right?
Yeah.
It really captures that feeling of interacting with the AI.
Yeah.
But where did that term actually come from? I'm curious about the origins of that.
Yeah, it's an interesting story, actually. The term really started to gain traction earlier this year thanks to Andrej Karpathy, who's a very prominent figure in the AI world. He mentioned it in a talk he gave, and it kind of took off from there. And the way he described it was really interesting. He said it's all about seeing things, saying things, running things, and copy-pasting things, which, when you think about it, that really captures the essence of this more intuitive, almost playful way of working with the AI.
Seeing things,
Yeah.
saying things.
Yeah.
It really highlights that direct interactive aspect of it. So the daily life of a programmer is starting to look pretty different with this approach, right? I mean, less focus on actually typing out every single command and more on this kind of higher level interaction with the AI.
Exactly. That's a really key point. The programmer's role is definitely evolving. It's shifting away from being the primary code writer and more towards being a guide, a tester, and someone who refines the code that the AI produces. And this also opens up some really interesting possibilities. For example, you could imagine individuals who haven't spent years, mastering complex programming languages, potentially being able to create functional software by simply describing what they need in plain language.
Wow. That's pretty profound when you think about it. So someone with a great idea, but maybe without the technical coding skills, could essentially just describe their idea, and the AI could translate that into a working application.
That's the potential, yeah. And what's really fascinating is that with vibe coding, users often accept and use the AI-generated code without necessarily having a detailed understanding of every single line of it. They trust the AI to have gotten it right. And this is actually a subtle but important difference from traditional AI-assisted coding, where developers would typically examine the AI suggestions very closely before incorporating them into their code. This acceptance without maybe deep understanding, it definitely raises some interesting questions and potential challenges down the line, which we'll get into a bit later.
Yeah, for sure. It's that classic balance, right, between ease of use and really understanding what's going on under the hood. I can definitely see how that could be incredibly empowering in terms of speed and accessibility. But also, like you said, there are those potential risks if users aren't fully aware of what the code is actually doing or if the AI makes mistakes.
Exactly. It's a double-edged sword in a way. And in our research, we definitely saw those contrasting viewpoints reflected. So on the one hand, you have the proponents of vibe coding who are really emphasizing that democratization aspect, the idea that it can bring software creation to a much wider audience, which is really exciting. But then on the other hand, you have the critics who are maybe a bit more cautious. Some of them see it as just a rebranding of existing AI assistants, and there's a concern that it might be oversimplifying the inherent complexities of building truly robust and secure software.
Right. So it's that classic tension between making things easier to use and the potential trade-offs in terms of deep expertise and control. Now, I'm curious, is vibe coding just a niche experiment at this point, or is it actually gaining real traction in the industry? What are you seeing in the research?
From what we've seen, it's definitely gaining momentum. There were some reports that came out recently indicating that a pretty significant percentage of new startups, especially those founded in the last year or so, are already using AI to generate a large portion of their code base. Now, it does seem like it's more prevalent right now for smaller projects and in educational settings, but larger tech companies are definitely exploring its potential as well, especially for internal tools and workflows. And we're also starting to see the emergence of these specialized AI-powered development tools that are designed specifically to support this more conversational way of coding.
That makes sense. I mean, startups are often a lot more nimble and willing to try out new approaches. Larger companies tend to be a bit more cautious. Now, I remember reading a story in one of our sources about a developer named Maya. Can you remind me what her experience with vibe coding was like?
Oh yeah, Maya's story is a great example. She was up against a tight deadline, and she was really struggling with a particular coding challenge. It involved sorting a list of numbers, but in a very specific way, where all the even numbers had to come before the odd numbers, and she was finding it surprisingly tricky to write the code for that. So just out of curiosity, she decided to try out this vibe coding thing that she'd heard about, and she just used natural language. She basically said to the AI, hey, I need a function that sorts a list this way, and described the specific sorting rule. And to her surprise, the AI was able to generate the code incredibly quickly, and it worked almost perfectly right away. It just needed a tiny tweak. And for her, it was this moment where she realized the power and the speed of vibe coding for certain very well-defined tasks.
Wow, that's a really great concrete example. It really brings it to life. So it sounds like vibe coding is showing a lot of promise. But based on the research, what kinds of tasks is it proving to be most effective for right now? Where are we seeing the most success?
Well, as we touched on earlier, setting up that initial boilerplate code, that kind of repetitive code structure that you need at the beginning of pretty much every project, that seems to be a sweet spot for vibe coding. Also, what are known as CRU'd operations, which stands for create, read, update, and delete. Those are like the basic ways that you interact with data in a lot of applications, and they lend themselves really well to this approach. And even generating those basic user interface components like buttons and forms and things like that, that also seems to be within the current capabilities of vibe coding.
Okay, so that gives us a good kind of foundational understanding of vibe coding, this more conversational approach to creating software. But now I want to kind of step back a bit and look at the bigger picture. What are the underlying technological advancements that are making all of this possible? What are the current capabilities of AI in coding in general that are kind of laying the groundwork for all these advancements?
That's a really important point. Vibe coding isn't happening in a vacuum, right? It's built upon the foundation of these increasingly sophisticated AI capabilities that we're seeing emerge in software development in general. And it's pretty remarkable how much AI can already do effectively in the coding world, even beyond just vibe coding.
So give us some specifics. What are some concrete examples of what AI can already do right now when it comes to coding?
Well, as we've talked about, generating that boilerplate is a big one. AI can automatically create those standard code structures that every project needs to get started, which saves developers a lot of time and effort. Code completion has also become incredibly advanced. AI can now predict and suggest entire lines or even blocks of code as you type based on the context of what you're writing. And it's gotten really good at that. And for simpler logical tasks, AI can actually generate functional code based on those natural language instructions. So it's not just filling in the blanks anymore, it's actually starting to create logic, at least for those more well-defined scenarios.
That's fascinating. So it's moving beyond just finishing your sentences, so to speak, to actually understanding what you want the code to do at a more fundamental level.
Yeah, exactly. And it's becoming more and more capable in that regard. Another area where we're seeing huge progress is testing assistance. So AI can help write unit tests, which are those small tests that verify individual parts of your code, as well as integration tests, which check how different parts of the system work together. It can even generate test cases to make sure that the code is robust and can handle different kinds of inputs. Debugging is also becoming more AI-powered. AI can analyze code, identify potential errors, and even suggest fixes or workarounds, which can save developers a lot of time and headaches. And even that basic code review process where experienced developers look through code to identify potential issues and suggest improvements, AI is starting to play a role there as well, by automatically flagging common problems and recommending best practices based on established coding standards.
It almost sounds like having a really helpful, tireless junior developer on the team, always there to lend a hand with those more routine tasks.
Haha, yeah, that's a good analogy. And just to give you some even more concrete examples, in our research, we came across mentions of AI being used to generate those CRU'd operations we talked about earlier in frameworks like Django, which is a popular web development framework, and also creating UI components using libraries like React, which is used for building user interfaces. And these are just a few examples. Beyond those core coding tasks, AI can also help with things like, catching syntax errors in real time as you're typing, assisting with complex pattern matching using regular expressions, which can be a real brain twister, even for experienced developers. It can even help translate code between different programming languages, which can be incredibly useful if you're working on a project that involves multiple languages. And it can even help improve the quality of the requirements documentation, which is that often overlooked but essential part of the development process. And of course, as we talked about with vibe coding, all these AI assistants are increasingly being integrated directly into those integrated development environments, the IDEs that developers use every day. So it's all becoming much more seamless and integrated into the developer workflow.
So the current state of AI in coding, it's already pretty impressive, it sounds like. But with all these capabilities, there must still be areas where it falls short, right? I mean, it can't be perfect. So what are some of the current benefits and limitations of using AI assistants in coding? What's the trade-off?
Oh, absolutely. It's really important to have a balanced perspective. There are definitely some amazing advantages, but it's not a silver bullet. So on the benefit side, we're definitely seeing faster development times. By automating those more routine and repetitive tasks, developers can focus on the more complex and interesting challenges, which can really boost productivity. And as we've discussed, it also has the potential to make software development more accessible to a wider range of people, which is really exciting. AI can also contribute to better code quality by suggesting best practices, helping to reduce human errors, and catching potential problems early on. And we shouldn't forget the potential for automatically generating documentation, which can save developers a ton of time and effort.
Yeah, all of that sounds amazing. But what about the other side of the coin? What are the limitations? Where does current AI encoding still struggle?
One of the biggest limitations right now is this lack of deep understanding of the overall context. So AI can be really good at generating a specific piece of code, but it often struggles with the broader picture of a large project. The overall architecture, the underlying business goals, how different parts of the code base are supposed to interact. And this can lead to code that might function correctly in isolation, but doesn't integrate well into the larger system. It's like asking someone to build a single brick without giving them the blueprint of the entire building.
That's a great analogy. It can write the sentences, but it doesn't necessarily understand the whole story.
Exactly. And because of that, there's still a real potential for errors, bugs, and even security vulnerabilities in AI-generated code. So careful human review and thorough testing are still absolutely crucial. Current AI also tends to struggle with those more abstract concepts, that complex logic, those intricate algorithms that require really advanced problem-solving skills. And dealing with unusual or unexpected input conditions, what we call edge cases, can also be challenging for AI models. as can working with older or less conventional code bases, AI is still learning, and it doesn't always have the experience to deal with those kinds of situations. And its ability to adapt to really novel or unique project requirements can also be limited. If you're trying to do something that's never been done before, AI might struggle to come up with a solution. And then there's the potential for over-reliance on these tools, which could lead to a gradual erosion of those fundamental coding skills in developers over time. If you're always relying on the AI to do the heavy lifting, you might start to lose those core skills. And then finally, maintaining and debugging code that was largely generated by AI can be trickier if the original developer doesn't fully understand how it all works, which again highlights the need for ongoing human oversight.
Right. So as powerful as AI is becoming, it's definitely not a substitute for human developers just yet. It's more of a tool, a very powerful tool, but still a tool that needs to be used carefully and thoughtfully. Now, one of the really intriguing concepts that came up in our research is this idea of the context window size. I'm hoping you can explain what that is and why it could be such a game changer for the future of AI in coding.
Absolutely. So the context window, it refers to the amount of information that an AI model can consider at any given time when it's processing input and generating output. You can think of it like the AI's working memory in a way. And the thing is, if we could significantly increase this context length, like some of the research we looked at was talking about context windows of up to 10 million tokens, that could completely revolutionize how AI understands and works with code.
10 million tokens, wow. That's hard to even wrap my head around. What kind of benefits would that unlock for AI encoding? What would it be able to do that it can't do now?
Well, with that much expanded working memory, AI models could hold and process so much more information simultaneously. And this would lead to much better overall understanding, greater accuracy in their responses. They could handle much longer and more detailed inputs, and in turn, they could generate outputs that are much more relevant and contextually appropriate. And specifically for those coding assistants we've been talking about, a larger context window means they could get a much more complete view of an entire software project, not just snippets of code here and there.
So instead of just seeing a few lines of code at a time, they can potentially see the entire project's code base all at once.
Exactly. And that would enable them to do some pretty amazing things. They could analyze and summarize extensive project documentation, understand how all those different code files relate to each other, and quickly find information from anywhere in the project. They could even start to reason about the project as a whole rather than just focusing on individual pieces of code. And it would make them much more effective at handling those complex questions and performing in-depth code analysis that spans multiple files. It's also a key step towards creating those more sophisticated AI agents that can maintain context over much longer interactions within a development project, effectively giving them a longer-term memory for the task at hand.
So can you paint a picture for us? What are some concrete examples of how a 10 million token window might change what an AI coding assistant could do in practice? What would that look like?
Sure. Imagine an AI that can effectively read and understand an entire code repository. Potentially millions of lines of code across hundreds or even thousands of files. It could grasp the overall structure, the coding style, the patterns, even the underlying business logic, and this would lead to much more context-aware code completion, where the suggestions aren't just based on the immediate lines of code, but on the entire project. It could also significantly improve bug identification because the AI could understand those dependencies between different parts of the code and see how a change in one area might cause a problem somewhere else. And we could see much more comprehensive code generation that automatically adheres to the existing project architecture and coding conventions. Tasks like documenting or refactoring entire software systems, or even conducting thorough security audits across the entire code base would become much more feasible. It'd be a huge step forward.
That sounds incredibly powerful. Are there any AI models already out there that are capable of handling those kinds of context windows, or is this still purely theoretical?
No, it's not theoretical at all. There are actually several models that are pushing those boundaries, and it's a very rapidly advancing area of research. Some models are specifically designed for working with code and boast really impressive context windows, much larger than what we were used to just a year or two ago. And then there are those more general purpose models that are also demonstrating impressive capabilities in handling longer sequences of information, including code. So we're seeing this clear trend where these more advanced AI models are offering significantly larger context windows, and that's only going to continue to improve in the coming years.
So this isn't just a hypothetical future, it's something that's actively being developed and implemented right now, which is really exciting.
Exactly. And, this larger context window, it also facilitates something called many-shot in-context learning, which is pretty fascinating. What that means is you can provide the AI with numerous examples within the prompt itself, and it can actually learn new coding styles or project conventions on the fly without needing to be completely retrained. It's like showing the AI a bunch of examples of how you want the code to look, and it can adapt to that style. And this also greatly improves the AI's ability to understand and handle those long dependencies in complex applications where you have data and control flow kind of weaving in and out of different parts of the code. And as we touched on earlier, the potential for those AI agents with this kind of extended memory to maintain context across longer interactions is huge. They could even analyze different approaches and weigh contradictory information within that large context to make more informed decisions about things like architectural design or resolving conflicting requirements. So the trend is definitely towards these larger context windows, and it's going to be a key enabler for much more sophisticated code analysis and generation in the years to come.
This whole context window thing, it really does sound like a pivotal advancement. Now, let's look even further ahead. What is this fully agentic coding vision that some of our sources were describing? What does that actually entail?
So fully agentic coding, it's a pretty ambitious vision for the future of software development. It's this idea that AI could eventually manage the entire software development lifecycle, the SDLC autonomously, without needing much, if any, direct human involvement.
Wow, that's a huge leap beyond even the advanced AI assistants we've been talking about.
Mm.
So what would that actually look like in practice? How would that actually work?
Well, it would encompass every single stage of the development process. So from understanding the initial user needs and defining the requirements, to designing the entire software architecture, writing all the code in whatever programming languages are needed, conducting thorough testing and debugging, deploying the application to the appropriate platforms, continuously monitoring its performance, and even identifying and implementing those enhancements based on user feedback and evolving needs. It would be a truly end-to-end process managed entirely by AI.
So the AI wouldn't just be writing the code, it would be making all the strategic decisions about what to build and how to build it too.
That's the ultimate aspiration, yeah. It would require AI systems with some incredibly advanced capabilities across a whole range of areas. So it would need to be able to truly understand natural language, to really grasp those user needs and translate them into technical requirements. It would need deep expertise in software architecture and design to effectively plan out these complex systems. It would need strong algorithmic thinking skills to solve problems efficiently. It would need proficiency in coding across multiple programming languages. And it would need really sophisticated abilities in automated testing and debugging to ensure that the software is reliable and functions as intended. And beyond that, it would need to be able to seamlessly integrate with all those different deployment and infrastructure management processes. And it would need a capacity for continuous learning and adaptation based on those real-world usage patterns. It's a tall order, to say the least.
It definitely sounds like it. So what are the key technological hurdles that we need to overcome to make fully agentic coding a reality? What would need to happen?
You're right. The technological bar is pretty high. So first of all, we'd likely need some really substantial advancements in artificial general intelligence, or at least highly specialized AI systems with capabilities far beyond what we have right now. And these AI systems would definitely need those extremely large context windows we were talking about earlier to really understand and reason about entire software projects. We'd also need to develop much more robust and reliable AI agents, which are basically those software entities that can plan, execute, and monitor these complex, multi-step tasks autonomously. And these agents would need to be able to handle unexpected situations, learn from their mistakes, and adapt to those changing circumstances without needing constant human intervention. They'd need to be a lot more independent than the AI systems we have today.
It's almost like creating entire digital software development teams, right, within the AI itself.
In a way, yeah. And then beyond that, we need these advanced AI-driven testing, debugging, and security analysis tools that can effectively identify and resolve those issues without needing a human to come in and fix things. And seamless and secure integration with all the various development tools, platforms, and underlying infrastructure would be absolutely crucial to truly automate that entire SDLC. And finally, we'd need some sophisticated mechanisms for the AI to gather and interpret user feedback, really understand how the software is being used in the real world, and then use that information to continuously improve the application. So it's a long list of challenges for sure.
Yeah, no doubt. Now, looking at the path from where we are today to that kind of future vision, Our sources outlined a potential series of evolutionary stages, kind of stepping stones along the way.
Yeah.
Can you walk us through those? How do we get from here to there?
Absolutely. So the journey from the AI-assisted coding that we see today, which includes vibe coding, to fully agentic coding, it's likely to be a gradual process. It's not going to happen overnight. And AI will kind of take on more and more responsibility over time. So the first stage, which we're largely in right now, is what we could call enhanced AI assistance. And this is where AI is helping with those tasks like code generation, completion, basic debugging, based on those natural language prompts and its growing contextual awareness. And the human role here is primarily guiding the AI, refining its output, doing that basic testing, and making sure everything is on track. And the key outcome here is really increased productivity in those more routine tasks. AI is handling a lot of that boilerplate and simpler logic, which frees up human developers to focus on the more challenging and interesting stuff.
Okay, so that's where we are right now. What's the next step in this evolution?
So the next likely stage is what we could call AI-driven code generation and testing. And in this phase, we'd start to see AI generating those more complex blocks of code and even entire modules autonomously without needing as much human input. It would also be capable of automatically generating those unit tests, those tests for individual components, and identifying more of those common types of bugs. So the human developer's role would shift a bit more towards defining those high-level specifications and then reviewing and refining the AI-generated code and tests, making sure that it all meets the requirements. And the key advancement here is that AI would be generating a much more significant portion of the code base, and that automated testing would become standard practice, which would really reduce the need for manual testing and debugging.
So AI is stepping up its game, taking on more responsibility. What comes after that?
The next stage we could call AI-augmented software design and architecture. And at this point, AI would actually start suggesting optimal software architectures, user interface and user experience layouts, and even overall system designs. It might even be able to generate those initial mockups and technical specifications. And the human role would then shift towards defining the overall requirements and constraints, and then reviewing and refining the AI-generated designs and specifications, making sure they're on the right track. And the key benefit here would be AI's contribution to those high-level design decisions, which could lead to automated generation of design documentation and just much more efficient planning processes overall.
So AI is moving beyond just writing code at this point. It's starting to help plan the entire structure of the software.
Exactly. And then the progression continues to a stage we could call AI integrated DevOps and deployment. And in this stage, AI would become much more involved in automating those continuous integration and continuous deployment processes, or CI/CD for short. So it would be managing the underlying infrastructure, monitoring the application performance in real time, and even predicting potential issues before they occur. And the human role here would be more about overseeing those deployment processes, making sure everything is running smoothly, and defining the key performance metrics and thresholds. So the idea is that AI would be managing those more day-to-day operational aspects of software development, which could lead to less downtime and more reliable systems.
It's almost like AI is becoming a system administrator at this point, too.
Yeah, in a way, it's definitely taking on more of those operational responsibilities. And then the next stage our sources outline is what they call semi-autonomous software development. And in this phase, AI would actually be capable of handling the end-to-end development of specific features or even entire modules with only minimal human oversight. So the human developer would define those high-level requirements, review the AI's output, and provide that kind of strategic oversight. But the AI would be doing most of the heavy lifting. And the key here is that AI can independently develop and deploy certain components of a software project, with the human role shifting even further towards high-level strategy and away from that direct coding.
So we're really getting closer to that full autonomy vision now. What's the final step in this progression?
Right. The culmination of all these stages is that fully agentic coding vision that we discussed earlier. And this is where AI is autonomously managing that entire SDLC, from those initial requirements all the way through to those ongoing enhancements, with the human role really focusing on those overarching business goals and the high-level vision. The AI would essentially be able to develop and maintain these complex software systems on its own, which would lead to a pretty significant transformation of the entire software development profession. But it's important to remember that this is a likely progression, and it's not going to happen overnight. Each stage builds upon the advancements of the previous one, and we're clearly in those early stages right now. But those future stages, they definitely involve increasing levels of AI responsibility and autonomy.
It's a really fascinating roadmap. It makes you wonder, with all these changes on the horizon, what's going to happen to the human developers? What are the experts predicting about how their role will evolve? Because it sounds like their jobs might look very different in the future.
Oh, absolutely. The experts are definitely anticipating a pretty significant transformation. They see AI as dramatically enhancing the speed, accuracy, reliability, and security of software development. Some even believe that generative AI could fundamentally reshape those traditional methodologies that we use to build software. And the big prediction is the shift in the human developer's primary role, moving away from primarily writing code to more of a role of guiding AI through those natural language instructions, defining those high-level goals, and making sure that the AI is on the right track.
So the ability to communicate effectively with AI will become a really core skill for developers going forward.
Absolutely, that's going to be crucial. And those AI coding assistants, they're expected to become much more contextually aware, like we were talking about earlier. They'll develop a deeper understanding of those project structures and objectives, almost like having a very knowledgeable and tireless collaborator working alongside you. There's also potential for vibe coding to merge with those no-code and low-code platforms, which could make software development even more accessible to individuals who don't have those traditional coding backgrounds. And the idea is that AI will handle a lot more of those routine and preparatory tasks that take up so much developer time right now, which would free up human developers to focus on those more creative and complex aspects of their work, the higher level problem solving, the strategic thinking, the things that really require human ingenuity.
So the human element is still considered essential, even in this future where AI is playing a much bigger role.
Absolutely. The consensus among the experts is that human oversight will remain crucial for the foreseeable future. Humans will likely retain control over those important approvals and final decisions, with AI acting as a powerful tool to augment their judgment and domain expertise rather than completely replacing them. So while AI might indeed... Yeah, that's a really important question. As AI takes on more of those direct coding responsibilities, human developers will need to really cultivate that deep understanding of overall system architecture and how to ensure long-term code quality. Because even if the AI is writing the code, someone needs to be able to understand how it all fits together and make sure it's well designed and maintainable. And mastering the art of providing those clear and effective instructions to AI, what's often called prompt engineering, that's going to become a really key skill. Being able to clearly communicate your intent to the AI and guide it towards the desired outcome, that's going to be crucial. And we're likely to see more and more of those hybrid human-AI workflows where humans and AI are working closely together, leveraging AI for those specific tasks while humans handle the more complex logic and strategic thinking. And the field of AI prompt engineering itself is likely to become its own area of expertise. And overall, that focus for human developers will likely shift more towards those higher level tasks like architecture, design, and that really deep understanding of the underlying business logic. And software engineering education, it will also need to adapt to this new reality. It'll need to emphasize things like adaptability, the ability to learn new tools and technologies quickly, and those new skills that are required to work effectively in that AI-driven development environment.
It really sounds like the future of software development will be all about that partnership between humans and AI, each bringing their unique strengths to the table. So as we wrap up this deep dive, what are the key takeaways from our exploration of vibe coding and this whole path towards fully agentic coding? What are the big ideas that we should all be thinking about?
Well, to kind of sum it all up, vibe coding is an early but really significant step towards this future where AI plays a much more central role in software creation. And it's all about leveraging natural language to guide that AI code generation process, which has some really exciting possibilities. But it also brings up those new considerations around code understanding, long-term maintainability, and making sure that humans are still in the loop. And that vision of fully agentic coding, where AI is autonomously managing that entire software development lifecycle, that's a multi-stage journey. It's going to require some really significant advancements in AI capabilities across a whole range of areas. But the general consensus among the experts is that AI is more likely to augment human programmers rather than replace them entirely. So those skills required of developers, they're definitely going to evolve with a greater emphasis on those higher level tasks like architecture, design, and that effective collaboration with those AI tools. And ultimately, the future of software development is likely going to involve this really interesting collaborative partnership, leveraging those unique strengths of both humans and AI to create more efficient, more reliable, and more innovative software solutions.
That's a fantastic overview. And on that note, here's a final thought for you to consider. Think about how these evolving technologies might impact your own work, your own career, or even just your understanding of software in general. what aspects of software development do.